Hey guys, today we're looking at lesson 9.2 and we're going to be looking at graphing logarithmic functions. Alright, so I have showed you how to graph logarithmic functions using your graphing calculator, which is very handy, and that's kind of what you will do most of the time if you're just looking for key features. But one of your major standards is transformations. So we do need to look briefly at transformations of logarithmic functions. And so we're going to start with task 2. Alright, you've seen graphs of f of x equals log base 2 of x, f of x equals log of x, and f of x equals ln of x, which is your natural log. Graphing transformations of these parent functions and of parent logarithmic functions with other base work in the same way that you have seen before. Recall that the reference point 0, 1, and 1b helped you graph transformations of parent exponential functions of the form f of x equals b to the x. Because of the inverse relationship between logarithmic and exponential functions, this means that 1, 0 and b 1 are the corresponding reference points for logarithmic functions. So you can see 0, 1 now is going to be 1, 0 for a logarithm, and 1b goes to b1. So these are the reference points for exponentials, and then these two will be the reference points for a logarithmic function. Alright, so you can see f of x here would be your parent function, and here are your reference points 1, 0 and b1. Remember, b is your base, and then it has an isotope of x equals 0. Alright, so g of x equals a times log base b times x minus h plus k. And you can see this is very similar to lots of other functions that we've looked at. So h is going to be your horizontal movement, and it's going to be opposite h every time. And then plus k is your vertical movement, so this moves you up and down. And then a is your vertical stretch, and b is your horizontal stretch or compression. Alright, so your reference points for a transformation is going to be 1 plus h comma k, and then b plus h comma a plus k. And then your isotope will be whatever h is, because h again is your horizontal movement. Alright, so let's look at the graph of g of x equals 3 times log base 4 of x minus 2 plus 8. Alright, so it says identify the parent functions, its base, and its parameters. Well, you can see that 3 is your a, that's your vertical stretch by a factor of 3. H is 2, so it moves it right 2 units. K is 8, and that moves it up 8 units. And if you want to just look at what this graph looks like, okay, so we can go to our graphing calculator, and I think I already have it in here. So I've typed in 3 log base 4 of x minus 2 plus 8, and when I hit graph, it kind of looks a little bit funny on your graphing calculator, because this actually should continue down. It gets closer and closer to the isotope. It doesn't actually touch it, and it's not a vertical line, so your calculator has a hard time graphing these points. Let's change the window and see if that helps at all. So let's change our x minimum to -5 and our x maximum to 5. And see how it kind of went down a little bit there. But it should just kind of gradually come down. It is a function, which means the x's are different, and it's getting closer and closer to that isotope, but it doesn't actually just stop. But you can see if you go to a certain point, if you look at the table of values, it does say error past where the isotope is. So anything past the isotope is just going to have an error sign. But there are lots of fractions or lots of numbers that could fit in there. Alright, so it says, why is h equal to 2 and not -2? Well, that's because, again, in the formula, it's x minus h, so it's like x opposite h. So that just tells me I'm moving it to the right, even though it looks like it's negative. All right, for the reference points and the isotope for the parent function and for g of x, f of x equals log base 4 of x. The reference points is 1, 0 and b1. And b1 equals 4, 1. Again, your base, your b is your base here. It's supposed to be a subscript, but I guess they don't have a way to write a subscript here. But b1, and the isotope would be x equals 0. All right, so they're calling this our parent function. And then g of x is the transformation. So g of x is a is 3, and then h and k, we've got h2 and k8. So the reference points are 1 plus h. So 1 plus h, we would add 2, and that's how they get 3. And then k would be 8. And then the other reference point comes from doing b plus h and a plus k. So b plus h and a plus k gives you the 6 and 11. And the isotope moves to x equals 2. Again, that's your horizontal movement, so it moves your isotope over as well. How can you find the coordinates of the second reference point of g of x? Select all that apply. Okay, again, that's going to be b plus h and a plus k. All right, so down here it says by substituting b, a, h, and k into b plus h and a plus k, so that is correct. That just comes from the formula above. By translating 4, 1, 2 units right, vertically stretching it by a factor of 3, and translating it up 8. So this tells us that's our vertical factor of 3. This moves it right 2 units, and this moves it up 8. So this one is also true. All right, by substituting 3, 4, 8, and 2 into b plus h and a plus k. So here they have the b and the a switched, and they have the h and the k switched. So that is not correct. Even though it looks very similar, they have switched the numbers around. And this says by finding the coordinates of any point and adding 2 to the x and 8. Well, this one, they are leaving off the vertical stretch by a factor of 3. They're leaving off the a term there. So that one is not true either. So it's just the first 2. All right, it says graph the transformed function. All right, so it says the unlabeled blue point on the graph f of x. Okay, so this point here above has coordinates 16, 2. How can you verify that the unlabeled green point on the graph of g of x is its image? So they're saying, how do you know that this point goes to this point here? So the translation right 2 units means adding 2 to the x coordinate. So we move 2 to the x coordinate, 16 to obtain 18. The vertical stretch by a factor of 3 and the translation up 8 units means multiplying the y coordinate 2 by 3, because our vertical stretch of 3, and then adding 8 to obtain 14. All right, so that is all for task 2. So again, that's how you use transformations to graph logarithmic functions. Again, these things right here will be very helpful when you're graphing using transformations. If you have any questions, please let me know.